factoring completely. Factoring completely means you want to try to factor everything that can possibly be factored in one problem. Sometimes you can factor one thing. Sometimes you could factor nothing. Sometimes you'll be able to factor 2 or 3 times. It just depends. But you're supposed to try to factor everything that you can. Now, here's a little process you go through. First thing you do is you check for GCF. That is the first step. If the problem has a GCF, you want to factor that first. Next, you try to factor based on the number of terms. We only have 3 types of problems right now that we're factoring. We have one with 4 terms, which is the grouping method. One with 3 terms, which is the trinomial, and if it's got 2 terms, it could be a difference of 2 squares. So we want to look at the number of terms and factor based on that. Once we get through to step 2, then we're going to check our answer for a difference of 2 squares. Sometimes you can factor the answer one more time, and I'll show you some of those too. Don't worry about that. Now, let's just start with this first example. My instructions say factor completely, so we're going to look for a GCF. So does it have a GCF? Well, notice all 3 terms have an x in common. So we can factor out an x out of each term, and we're left with this. Now, I look at this to see if we can factor it. Now, this is a trinomial, so we have to determine, are there any factors of 2 that add up to be 3? And the answer is yes. So we can factor this as x plus 1, x plus 2. This is the final answer. This is factored completely. So we had a GCF we could do first. We had a GCF. Then we were able to factor the trinomial. Let's look at this one. GCF. Does it have a GCF? Well, notice they both have x's, so we can factor out one of the x's. That's the GCF. Then we look at this to see if we could possibly factor this. Well, this is one of those special difference of 2 squares. X minus 3, x plus 3. This is the final answer. GCF, and then we had a difference of 2 squares. Look at this one. Same thing. Look for GCF. Does it have a GCF? This time the answer is, again, yes. Notice they both have 4's in common, so we can factor out a 4, and we're left with x to the 4th minus 1. Alright, so we have the GCF. Definitely got a GCF. Now let's try to factor this. Now it's 2 terms, and this is one of those special difference of 2 squares because it's got the minus sign in the middle, it's got the even exponent, and I can take the square root of 1. So we break this apart. X squared minus 1, x squared plus 1. Now what I was talking about earlier, check the answer to see if you might have a difference of 2 squares. This answer can be broken down one more time. So I can do the one with the minus sign. I can't do the one with the plus sign because it's not a difference of 2 squares. This is the final answer. I was able to do this one twice. GCF first, then the difference of 2 squares, then another difference of 2 squares. All right, let's check this one. Let's check for GCF. So So can I divide all of those coefficients by the same number? And the answer is yes. The 2, the 8, and the 6 all divisible by 2. Factor out the 2, and we're left with this. Now, I look at the trinomial and try to factor it. So I got to check to see if there's any factors of 3 that add up to be -4, and the answer is -3 and -1. And if you have to list out the factors, list them out. -1, -3, 1, 3. This is the final answer. Look at this one. Let's check this one for a GCF. Well, the 3, the 6, and the 9 are all divisible by 3. And they also have an x in common. We can factor out that x. So we're going to be left with x squared minus 2x minus 3. So we got the GCF. Now we got to try to factor this trinomial. Well, come over here and list all the factors of -3 and see if there's one that adds up to be -2, and it is. X minus 3, x plus 1. This is the final answer. Let's look at this one. Now this one's got 4 terms. I'm going to tell you a little secret on this one. On the 4 terms, no GCF on the 4 term. So we're just going to do this like we've done in the past, where we draw the 2 sets parentheses with the plus sign in the middle. Put the x cubed and the 5x squared in the first one. Put -4x minus 20 in the second one. Then we're going to take each parenthesis separate and factor. This one we can pull out an x squared. We're left with x plus 5. This one, pay attention, there's a minus sign here. So my GCF will be a -4. That gives me x plus 5. You got to remember that they work, they have to match. Then that x plus 5 is the matching part of the answer, and the other part is the x squared minus 4. So this one had no GCF. No GCF. But it was a grouping problem, so we grouped it and got to the end. Now I'm down at this step. I have to check my answer to see if it could possibly have a difference of 2 squares. And notice right here, this is a difference of 2 squares. So we can factor it one more time. This is the final answer. Now look at this one. Let's see if we can factor something out of this one. Well, let's check for GCF. Does it have a GCF? Well, there's nothing that can divide into 1, 7, and 3, so it doesn't have a GCF. They don't all have x's in common, so there's no GCF. No GCF, so that's okay. Now, it is a trinomial, though, so let's try to factor the trinomial. So we want the factors of -3 that add up to be positive 7. Well, I hope y'all can see that none of those work. So, no GCF. I can't factor it. Its answer would be prime. Sometimes you can't do anything. All right, so pay attention. You don't have to be able to factor anything. It may just be nothing. Now let's look at this one. Well, let's check it for a GCF. Does it have a GCF? Answer is no. Now, it's got two terms though. So let's ask this question. Is it a difference of two squares? Well, I don't know. Does it have a minus sign in the middle? And of course the answer is no. So we cannot factor it. And if we can't factor it, we say the answer is prime. Alright, I want to do another one. Let's say I had x to the fourth plus 5x cubed minus 12x squared. So the first thing we're going to do is look for GCF. We factor out the GCF, which is x squared. And then we're left with this. So we definitely had a GCF. Now, let's go try to factor this trinomial. So let's list all the factors of negative 12 and see if we could possibly find one that adds up to be positive 5. Well, that one doesn't work, 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 that one doesn't work. I can't factor this trinomial. This cannot be factored. So the answer is x squared times x squared plus 5x minus 12. Some of you were probably thinking, okay, it's prime because I can't factor that. Well, guess what, y'all? If you got a GCF, it ain't prime. If you can't factor anything at all, it's prime. If you can do any factoring, it's not prime. It's just you may not be able to do but one thing. So don't assume it's prime just because you can't factor one part of it. The other part you were able to factor. All right, try it. This is the last thing I'm doing. Try to do the homework on this stuff. Email me if you got any questions before you take the quiz. Do not take the quiz until I post the homework solutions. I want to make sure that you're getting it right. So don't try to do it if you're not sure.